Assalamu alaikum wa rahmatullahi wa barakatuh. Hi everyone, nice to meet you all. Today inshallah we will start together in the first lesson of quantitative chemistry. Quantitative chemistry is one of the most important chapters in your syllabus for IGCSE. Take care, this chapter will be repeated again with you in AS level. It will be repeated again with you in grade 11 in studying the quantitative chemistry. Now we will start with the first lesson, relative atomic mass and relative molecular mass. Relative atomic mass of an element AR and relative molecular mass of an element MR. In this chapter, you must try to understand each point to know how can you calculate each point in your chapter. You must be with me step by step from the beginning. At first, we studied before that any element is written in the periodic table as, for example, C612. Each element symbol is surrounded by two numbers. One of the numbers is the atomic number. Atomic number is the number of protons. And we have atomic mass. Atomic mass number, it is the sum of proton number plus neutrons number. Inside the atom, we can say that the atomic mass, the mass of any atom, is concentrated in the mass of its nucleus. Why it is concentrated in the mass of its nucleus? Why we neglect the mass of electrons? Because the mass of protons equals the mass of neutrons equal 1 atomic mass unit, while the mass of electron equal 1 over 1840 atomic mass unit. So when we start to calculate the mass of electron, we can say we have one orange and we start to distribute our orange between 1840 persons. It is impossible. Each one will take nothing. So we can neglect the mass of electrons. Mass of our electron is neglected. It is the atomic mass. It is the mass of proton and neutrons mainly. So we can say that the mass of atom equals the mass of ion. Ion is atom which lost or accepted electrons. How many electrons it will lost or accept? At most 7 electrons. If it lose or accept 7 electrons, also the mass of electrons lost or accepted is neglected. So we can say that the mass of atom equals the mass of ion. Take care, each point is important, okay? Now, we say that it is impossible to calculate the mass of atom by gram, by kilogram. It is impossible. The mass of atom is very, very, very small. So it is impossible to weigh the atom directly. It is impossible to calculate it in kilogram or gram. So we want to calculate the mass of atom by using scale. According to the importance of carbon atom in organic chemistry, they started to take the carbon 12 as our scale units. Like our carbon 12 exactly equal to 12 units on our scale. So each one unit equal 1 over 12 of carbon 12. Again, each one atom of carbon 12 equal 12 mass units. 1 by 12 of the mass unit of carbon 12 equal 1. So we can say that the relative atomic mass AR is the average mass of an element. of naturally occurring atom of an element on a scale where the carbon 12 atom has a mass exactly of 12 units. Relative atomic mass AR equals the mass of an element divided by 1 by 12 of the mass of carbon 12. So it is the relative atomic mass of an element is the element of an atom divided by 1 by 12 of the mass of carbon 12. It is the relative atomic mass of an element. Now we will start to know how we can use the relative atomic mass in calculating the relative molecular mass. We have different elements from the periodic table, and we will start to know that the relative formula mass or the relative molecular mass MR. It is the sum of the relative atomic masses of an element present in the formula unit. So, relative formula mass, relative molecular mass MR is the sum of relative atomic masses of the elements present in the formula unit. We will start to calculate the relative molecular masses of the following compounds. MR of the following compounds. At first, we will start with the carbon dioxide. Carbon dioxide is molecule, consists of one carbon atom and two oxygen atoms. We want to calculate the relative molecular mass of carbon dioxide. Relative molecular mass of carbon dioxide is the sum of the relative atomic mass of one carbon atom, so AR of one carbon atom plus AR of oxygen atoms. But take care, we have two oxygen atoms, so we will multiply it by 2. So we will know how we can calculate the relative molecular mass of carbon dioxide. At first, we want to know relative atomic mass of carbon atom equal 12. 2 times the relative atomic mass of oxygen atom, because we have 2 oxygen atoms. 2 times 16 equals 32. Total relative molecular mass MR equal AR relative atomic mass of carbon plus 2AR for oxygen. So the relative molecular mass of carbon dioxide total equal 12 plus 32 equal 44. From where the elements? From our compound elements. Carbon C612. Oxygen O8 16. So we can calculate the relative molecular mass of carbon dioxide. Next one, oxygen O2. Oxygen is one of gases. Oxygen is diatomic gas. So each molecule must contain 2 atoms of oxygen. We have oxygen O2. So we have 2 times AR for oxygen. So we have 2 times the relative molecular mass of oxygen. Oxygen is O816. 2 times 16 equals 32. So we have 2 times the relative atomic mass of oxygen. 2 times 16 equals 32. Next one. Ammonia solution. You must know the symbol of your compound. Ammonia solution in H4OH. We studied ammonia solution in acids and bases. Okay? So we have 1 nitrogen atom. We have 4 plus 1. We have 5 hydrogen atoms. And we have 1 oxygen atom. So we can say that MR relative molecular mass equal Ar for nitrogen, relative atomic mass of nitrogen, plus we have 5 hydrogen atoms, 5 times relative atomic mass Ar for hydrogen, plus 1 Ar relative atomic mass of oxygen, Ar for oxygen. So we can say that Mr, relative atomic mass of nitrogen, is 14. 5 times relative atomic mass of hydrogen is 1. 5 times 1 equals 5, plus Ar for oxygen equals 16. So at first, relative atomic mass of nitrogen 14, relative atomic mass of oxygen 16, 4 times the relative atomic mass of hydrogen, we have 4 plus 1. So 4 plus 1 equal 5. So the relative molecular mass of ammonia NH4OH, 14 plus 4 plus 16 plus 1. So it is 34 plus 1 equal 35. So take care, my student. We have 35 is the relative molecular mass of ammonia solution. Next one, sulfur dioxide. Sulfur dioxide, Mr relative molecular mass of our compound equal Ar relative atomic mass of sulfur plus 2 times relative atomic mass of oxygen, because we have 2 oxygen atoms. So we can say that relative atomic mass of sulfur 32, 2 times relative atomic mass of oxygen, 2 times 16 equals 32, relative molecular mass equals 64. Next example, hydrated magnesium sulfate. Hydrated magnesium sulfate is one of complex compounds. So you must know exactly the number of atoms in your compound. We have 1 magnesium atom, 1 sulfur atom, 4 oxygen atoms. And we have 7 water molecules. So we can say that Mr relative molecular mass equal the relative atomic mass of magnesium Ar for Mg plus Ar for sulfur, Ar for sulfur, plus 4 times Ar for oxygen atom, plus 7 molecules times the relative molecular mass of water molecule. Water consists of 2 hydrogen atoms, 2 Ar for hydrogen, plus 1 Ar for oxygen. So we can calculate it. Relative atomic mass of magnesium 24, relative atomic mass of sulfur 32, 4 times the relative atomic mass of oxygen atom, and then we have 7 water molecules. So 7 water molecules, 7 times 2 Ar for hydrogen, 1 Ar for oxygen, 7 times 2 plus 16, 7 times 18 equals 126. So the total relative molecular mass of hydrated magnesium sulfate equals 24 for magnesium, 32 for sulfur, 64 for 4 oxygen atoms, and 126 for 7 water molecules equal 246. Okay, it is the relative molecular mass of magnesium sulfate hydrated. After this calculation, you must know how can you calculate the relative molecular mass of a compound. Okay. Now we will transfer how we can calculate the percentage composition of compound. If we have compound like, for example, magnesium sulfate hydrated, and we want to calculate the percentage of water molecules in hydrated magnesium sulfate, how can we calculate the percentage of an element in composition of compound? At first, calculate the relative molecular mass of the compound. Then, calculate the relative atomic mass of an element. And then, to calculate the percentage of a compound, you must calculate the relative atomic mass of an element divided by the relative molecular mass of compound times 100. So, to calculate the percentage of composition of compound equal, at first you must calculate the relative molecular mass of your compound Mr. Then you must calculate the relative atomic mass of your element Ar. Then divide the relative atomic mass of an element Ar over the relative molecular mass of an element Mr times 100. Example. We want to calculate the percentage composition of copper in copper sulfate. We want to calculate copper in copper sulfate. So, the relative atomic mass of copper Cu2963.5. Approximately, we can say it is 64. So, relative atomic mass of copper is 64. Divided by relative molecular mass of copper sulfate, 64 plus 1 sulfur atom, 32 plus 16 times 4. Total times 100. So we will find it is 40%. Example. What is the mass of copper in 250 grams of copper sulfate? We have 250 grams of copper sulfate. We want to calculate the mass of copper in our sample. We know that mass of copper equal percentage composition times mass of compound. In our compound we said we have 40% for copper. If the total mass is 250, each 40% of copper, how many grams? Just the mass of copper equal its percentage times the total mass of compound. So it is 40 times 250 equal 100 grams. At home, start to calculate the percentage mass of water in crystals of hydrated magnesium sulfate, MgSO4 7H2O. What is the percentage mass of nitrogen in compounds of ammonium nitrate? Ammonium nitrate, NH4NO3. Now we will start in the next topic. Calculating the empirical formula of compound in the lab. You are working in the lab and you have magnesium ribbon and you will start to burn it in oxygen to form magnesium oxide. So at first we must use crucible. In the crucible we will start to add the magnesium ribbon and we will start to heat it at high temperature. Each time we will remove the lid of your crucible and you start to react magnesium with oxygen, and at last we will have magnesium oxide. Magnesium oxide is the oxide of magnesium formed from the reaction between magnesium and oxygen. When you remove the lid and we have no more reaction, we have no more burning reaction with oxygen, so our reaction is finished. So we will stop heating. You must take care of the technique for making the experiment inside your lab. Just by removing the lid, and we have no more reaction with oxygen, we have no more burning reaction, we can say that our reaction is finished. Okay? Now we can say that the empirical formula of compound can be determined from the masses of elements that combine together in the chemical reaction. Take care, these calculations are important because we have magnesium Mg will react with oxygen O2 to form magnesium oxide MgO. We need to balance our equation at 2 for magnesium and 2 for magnesium oxide. So each 2 magnesium atoms will react with 1 oxygen molecule to form 2 molecules of magnesium oxide. Inside the lab, we can calculate the mass of reacted magnesium ribbon and the mass of the final magnesium oxide. So we can calculate the mass of magnesium ribbon at the beginning of the chemical reaction and the mass of magnesium oxide formed by the end of the chemical reaction. By calculating both of them, we can start to draw relation between the number of or the mass of magnesium and the mass of magnesium oxide formed. So we can calculate the mass of oxygen involved in the chemical reaction. Determination of the empirical formula of magnesium oxide. At first, practically, you will start to calculate the mass of your crucible and the lid. For example, it is 21.02 gram. Number 2, we will calculate the mass of crucible, mass of lead, and mass of magnesium ribbon. It is 21.5 gram. So we can calculate the mass of magnesium ribbon involved in our reaction from the calculations. By the end of the reaction, we can calculate mass of crucible, mass of lead, and mass of magnesium oxide. It is 21.82 gram. From these calculations, we can calculate number of oxygen or the mass of oxygen included in our reaction, and also number of oxygen atom. We will know in the next session, inshallah, how to calculate the mass or the number of oxygen molecules involved in the reaction. Take care, this experiment is included in most of questions in the exam related to practical questions and also related to the alternative practical questions in your paper. For example, if we have mass of magnesium and mass of magnesium oxide, we can calculate mass of oxygen. If we start with 5 grams of magnesium and finished with 8 grams of magnesium oxide, 8.3, so the mass of oxygen involved equal 8.3 minus 5 equal 3.3 grams. Next one, we start with 6.5 and finished with 10.8. So mass of oxygen 10.8 minus 6.5. So we can say that we have 3.3. It is the mass of oxygen involved. We have 13.6 and mass of oxygen is 9. So the mass of magnesium oxide equals 13.6 plus 9. 13.6 plus 9 equals 22.6. And we have mass of oxygen 12.5, mass of magnesium oxide 1.5 minus 12 0.5 equal nearly 9, I think 19 grams of magnesium oxide of magnesium will be used in the reaction. We can start to draw relation between mass of magnesium on x-axis and mass of magnesium oxide produced from the reaction. So we just draw relation between mass of magnesium we used in the beginning of reaction and mass of magnesium oxide formed after the reaction. By calculating and drawing the relation, you must be accurate as most as you can. Okay? We have example if we react 0.24 grams of magnesium with 0.16 gram of oxygen to produce 0.40 gram of magnesium oxide. How much magnesium oxide MgO will be produced from burning 12 grams of magnesium? At first, we have known information. Our known information, we start with 0.24 grams of magnesium to form 0.40 gram of magnesium oxide. And we start to use 12 grams of magnesium. How many grams of magnesium oxide will be formed? The mass of magnesium oxide formed is 12 times 0.4 divided by 0.24. We have 20 grams. Just use cross multiplication. For the students who will enter practical exam or who will enter alternative to practical paper, take care, he can ask you about factors of mass loss. Already in any experiment inside the lab, it is impossible to have 100% yield. It is impossible to do any chemical reaction without mass loss. So he can start to ask you what is the factors of mass loss in your experiment. At first, the reaction may not be totally completed. The reaction may not be totally finished. Number 2, errors may be made in weighting the reactants and products. It may be. Already we are humans. We have some problems. We have some mistakes. Materials may be lost in carrying out the reaction, and it is already the main factor of mass loss is the loss of materials in carrying out the reaction or in transferring and separating the products. Already in separation techniques, in purification techniques, we can lose very large amount of our yield. In homework, start your answer your POC questions, page 157, I think, page 157, okay? So we have finished our lesson today. You must know how you can calculate the relative atomic mass of an element from the periodic table. You must know how can you calculate the relative molecular mass of an element from the periodic table. You must know all of these calculations and how can you do it step by step in your exam. Thanks for watching our video today and wait the other video for calculations of mole. Don't forget to make like and share for the video, send it for your friends and make subscribe to have any new video in our channel. Thanks for watching our video. See you later. Assalamu alaikum warahmatullahi wabarakatuh.